right, welcome everyone. Let's dive straight into this explainer. If you're prepping for your Nutanix Certified Professional Multi-Cloud Infrastructure 7.5 exam, you already know that high availability isn't just some nice-to-have feature. It is literally the bedrock of enterprise infrastructure. Today, we are putting a massive magnifying glass on Objective 13.7, specifically the Metro Availability Witness. We're going to break down exactly what it is, how it drives automated failover, and most importantly, the strict rules and sneaky edge cases you are absolutely going to be tested on.
We have a super focused agenda today to get you fully exam ready. First, why the witness matters. Second, how it operates under the hood. Third, the edge cases and exam traps you need to watch out for. And fourth, the key facts you just have to memorize. Let's get right into it. Starting with Section 1, why the witness matters for Metro availability. To really understand the witness, we first have to ground ourselves in what Nutanix Metro Availability is actually trying to achieve in the first place. Metro Availability targets a 0 RPO, or recovery point objective. That means absolutely zero data loss. It also targets a near zero RTO, or recovery time objective, meaning almost instant recovery time. The goal is continuous data availability across completely separate physical sites. It does this by synchronously replicating data between an active storage container on your local cluster and a standby container on a remote cluster. Every single write is mirrored. But as you can imagine, keeping data perfectly synchronized across two sites introduces a massive operational challenge. Namely, how do you manage a sudden failure without causing total chaos? Well, that is exactly where the witness comes in.
Think about the middle of the night when a disaster strikes. Without a witness service in your environment, an administrator actually has to manually intervene. If your primary cluster goes down at 3 a.m., a real human has to wake up, log in, manually pause Metro availability, break the replication, and then manually fail over the entities using a recovery plan. In the middle of a disaster, manual steps cost precious time. But with a witness VM configured, the failover is a fully automated process. The system detects the issue, automatically pauses replication, and fails over the workloads all on its own. It's a lifesaver.
So the crucial point here is that the witness acts as a completely neutral tiebreaker. It manages leadership elections to prevent what we call a split brain scenario. Imagine a situation where the network link between your two data centers just drops, but both clusters are actually still running perfectly fine. Without a tiebreaker, both sites might assume the other site is dead, and both might try to promote their local storage containers to active. If that happens, both sites start writing different data to what is supposed to be the same synchronized container. That is split brain, and it is an absolute data corruption nightmare. The witness sits safely outside of both sites, arbitrates the failure, and ensures that only one site can ever take leadership.
Moving right along to Section 2, how the witness operates during an automated failover.
Take a look at how this architecture is physically laid out. We have Site 1 and Site 2 as our primary and secondary clusters, but notice the witness. It's purposefully located in Site 3, a completely separate third fault domain. This is essential. It means it has independent power and independent network connections. When Site 1 suffers a catastrophic failure, the witness detects this immediately because it loses communication with Site 1. But because the witness is still talking perfectly fine to Site 2, it can automatically disable Metro availability and promote the storage on Site 2, so your virtual machines just keep right on running.
Let's break down a very concrete example. A complete primary cluster outage. In this scenario, Site 1 completely loses power, goes totally dark. The controller VMs on Site 2 and the witness VM both instantly recognize the loss of communication with Site 1. Because the witness is configured and waiting, it steps in immediately. It automatically disables Metro availability on the primary side. This is crucial because it prevents any ghost writes from happening if that primary site happens to flicker back on. Then it promotes the secondary storage container to active. Your virtual machines seamlessly transition their I/O to the newly promoted active container without missing a beat.
Now for our second example, a network partition. Let's say both Site 1 and Site 2 are fully powered on, humming along, but a construction backhoe just cut the fiber connecting them. They are blind to each other. Immediately, both clusters are going to reach out to the witness VM and request a lock. It's a race, but a highly controlled one. The cluster that successfully acquires the lock from the witness assumes leadership and stays active. The other cluster, failing to get the lock, knows it lost the election and will intentionally not attempt to promote its storage. This absolute certainty guarantees zero split brain confusion.
Now, this automated process doesn't just happen randomly.
It operates on a very strict, precise timeline. From the exact moment communication with the primary site is lost, the system initiates the lock request process with the witness. Once that's validated, a timer starts ticking. It takes exactly 120 seconds from the time communication is lost to automatically promote the target storage container from standby to active status. That 2-minute window is a hard-coded metric, and you absolutely need to commit it to memory for the exam.
While we are deeply focused on the witness today, you must understand all 3 operational modes for the exam so you can contrast them. Witness mode, as we've seen, automates everything, failover and promotion. But you also have automatic resume mode. This mode prioritizes VM availability. If the connection drops, VM writes will automatically resume locally after just 10 seconds, basically sacrificing synchronization to keep the system up. Then there's manual mode, which prioritizes storage consistency over VM availability. In manual mode, writes will simply freeze until an administrator manually goes in and disables Metro availability. The exam is definitely going to test your ability to choose the right mode based on a given company's priorities, so keep these clear in your head. All right, Section 3, Edge Cases and Exam Traps. Pay very close attention here, because Nutanix documentation explicitly warns against the scenarios we are about to cover. If you remember only one single rule from this entire explainer, let it be this exact warning from the Data Protection Guide. You must never restore a witness VM from a snapshot under any circumstances. I am going to say that one more time. Do not restore a witness VM from a snapshot. It is completely unsupported for ESXi clusters configured for Metro availability.
And here is exactly why this is such a dangerous trap. Let's say a junior admin thinks they're being incredibly helpful and restores the witness VM from a snapshot to fix a minor issue. What they're actually doing is injecting old relationship state data back into a live active cluster. This creates what's called a stale configuration. It actively disrupts your Metro availability operations and severely impacts cluster reliability. The system will catch this immediately, and it will throw a critical alert. Alert 1339.5 stale witness VM. And here's the kicker. To fix it, you can't just reboot the machine. You are forced to completely redeploy a brand new witness VM and re-register it all over again via Prism element just to resume failure handling. It is a massive headache.
Another edge case you have to consider is the failure of the witness itself. What actually happens to your running VMs if the witness VM just goes offline? Well, the answer is nothing. A failure of the witness does not affect the VMs running on either your primary or your secondary sites. If it's just a temporary network blip, don't panic. When the connection is reestablished, the witness process resumes automatically without you lifting a finger. However, if the witness VM dies permanently, let's say the host hardware in Site 3 actually catches on fire, you have to deploy a brand new witness VM. Change your recovery modes temporarily over to manual, register the new VM with its default password to both sites, and only then can you switch the mode back to witness.
Finally, Section 4, Key Facts to Memorize. Let's synthesize all this into a few rapid-fire facts for your exam prep.
First up, the number 120. 120 is the exact number of seconds it takes to promote the target storage container from standby to active status once communication with the primary site is lost. Lock that number in. Next number, 9440. This is the crucial TCP port that absolutely must be open on your firewalls. Communication between the controller VMs on your Metro clusters and the witness VM happens exclusively over TCP port 9440. If this port is blocked, the witness simply cannot arbitrate a failover. Now let's talk VM specs. The witness VM is lightweight, sure, but it is incredibly strict on its minimum requirements. You need to provision exactly 2 virtual CPUs, 6 gigas of memory, and 25 gigas of storage. Furthermore, it absolutely must reside in a separate failure domain with independent power and networking. This is to ensure it doesn't accidentally become a single point of failure alongside your primary or secondary data centers. Also, take note of the scale limits. A single witness VM is surprisingly robust. It can support up to 50 Metro Availability Protection Domains, or PDs. However, this is strictly provided that the network latency between the clusters and the witness remains under 200 milliseconds. And that brings us to the end of our deep dive into the Metro Availability Witness. Before you close this explainer and get back to your studies, I want you to think really carefully about this scenario for your exam. If a junior admin restored your witness VM from a snapshot to, quote-unquote, fix an issue, triggering alert 130395, what exact sequence of steps must you take to resume failure handling? Think about the redeployment, the re-registration in Prism element, and how you have to handle the protection domains in the meantime. If you can master that workflow and memorize those metrics we just talked about, you are absolutely going to nail this section of the NCP-MCI 7.5 exam. Good luck studying, and I will see you in the next explainer.